Now continuing where we left off, we've just read the real and the imaginary part of ZA, and in order to get that in ohms, I need to multiply it by Z0, which is 50 ohms. That's going to give me 125 minus J, 27.5 ohms. Now let's see what our ZL is. ZL is 2 times pi, and that's about 6. So this is J, positive J, 6.28 ohms. If I want to know the input impedance, because this resistance is, or this impedance is in series with this one, Zn is just the sum of these two. So let's see what it is. Zn is going to be 125. Notice that this is strictly real. And then I'm going to take minus 27.5 and add 6.28, which gives me minus J, 21.22 ohms. That's the input impedance. If we now wanted to plot that on the Smith chart for some reason, perhaps because we were going to connect on more lengths of line, we would again normalize and plot, and so on. The thing that I would like to emphasize is when you have the inductor or a capacitor in series and its value is given in ohms, notice right here, the impedance is given in ohms, you have to be sure that the impedance that you are adding it to from the Smith chart is also in ohms, so you have to be denormalized. It is okay to add two values that are normalized or two values that are denormalized, but you can't add a normalized and a denormalized value. Just make sure everything's in ohms, normalized to ohms, and you'll be okay.